Okay, great. So this function is onto, if I take any positive number, then the ln of that serves as a pre-image to that number, because e to the ln of y is just y. Okay, great. So this is at least a bijection. It's got a chance of maybe being a homeomorphism. So my next question is, do you guys think that it's going to actually work? We have a bijection now, but do you think this is actually going to be one-to-one, that it's actually going to be continuous in both directions or not? Think it will work? Hey, how? So, you know, if you pick an open set here, right, then, and you can just treat it as an open interval because those are going to kind of form a basis. So if you pick an open interval here, it's very much like the homework that you guys did yesterday, that a lot of people didn't do it so good, so maybe I'll write it up more carefully here. Picking an open set, so let's let, I don't know, A, B be an open set in 0 to infinity. Okay? I like that blue either. So this is going to be where 0 is less than or equal to A, which is less than B, which is less than infinity. Okay? So then the question is... we
have to find the pre-image.
Right, the pre-image of that. So it might help to have the picture of the graph here. There's the graph of f of x equals e to the x. And so if I pick, like my open interval AB is like, you know, going to be somewhere maybe from here to here, right? It's in on the y-axis, right? So then if I look for the pre-image of that open interval, it's going to be kind of from there to there, right? This x value to this x value. So sort of this interval right here. And that's an open interval in the real number line. So I'm claiming that the pre-image of this open interval is an open interval. And in fact, we should be able to say what this actually is equal to. So this is actually, so if this is b right here as a y value, then what's this x value? Natural log of b, exactly. And if this is a y value of a right here, then what's the corresponding x value? The ln of a, exactly. And notice this one is to the left of this one, so that when we're putting it into an interval, we should write it just like that. Okay? So there you go. And of course, the ln of a could be a negative number. Nothing wrong with that, right? Because in the pre-image, capital X, you have all real numbers here. So, okay, so that this is still open in X. Okay. And then we also have to show that the inverse function is continuous. Actually, to be totally honest with you, you could just, because you're using the absolute value topology, which is the familiar one that you've used ever since you were in Math 150A, right? This function is known just from calculus to be continuous. This is not like we have to use Math 414 to prove it, right? Math 414 way of proving it would be to do this. Take a pre-image of an open set and show that it's an open set. But because this is an example of a function that you knew about many, many semesters ago, and as long as you're not using a weird topology on it, you could just use the fact that you know from your calculus courses that this is continuous. Same thing with the ln function, which is the inverse for this, right? So note that f inverse of x is going to be the ln of x, right? And that is also going to be continuous. The ln graph, of course, looks like this. Just draw a picture of it for you here. So again, if I take any open interval in the output side, so if I take any AB, so given AB inside of X, then the image of AB, give myself some more room here, the image of AB if we take F of that, now this is the same thing, guys, as the pre-image of F inverse of AB, right? It's the same thing. So this is just the pre-image of that. This is going to just be what? Actually, wait a second. Is this what I want to be doing? No. I'm taking the pre-image of, no, this is right. I'm taking the pre-image under F inverse of AB. So this is just F of AB, which is just what interval?
E to the A to E to the B.
Exactly. Which is open in 0 to infinity.